Now children, let's recall the section formula. What was the section formula? Any line or segment given to you and a point of intersection dividing that line in the ratio of m:n. How do we calculate the coordinates of that point of intersection? Here, as you observe, it is point P. So, the x coordinate is calculated by using the section formula as mx2 plus nx1 upon m plus n, and the coordinate of y with the formula my2 plus ny1 upon m plus n. This, as we have seen, was the section formula. Now let's take a special case, children. When the given point P is exactly the midpoint of that given segment, then what is the change in the formula? So to observe, let's see, AB is a segment where point P is exactly the midpoint. These identical marks show that P is the midpoint of AB. Once again, the coordinates of A and B will be x1, y1. Point B will be x2, y2. And point P, the coordinates will be xy. By using the section formula, let's see how we derive the midpoint formula. So children, x will be equal to mx2 plus nx1. But in this case, we see that m and n, both the ratios are equal. Why? Because P is the midpoint. So we have m is equal to n. So let's see what we get while finding out the coordinate of value of x. So mx2 plus, instead of writing n, I can resubstitute n as both are equal. So m x1 upon m plus n. So what do we get in the numerator? Let's concentrate on the numerator. M is common, into bracket x2 plus x1. Let's look at the denominator. In the denominator, let's see the change that should have been made. M plus n. But we know that n is equal to m. So also in the denominator, you can substitute it as m. So what do we get? M into bracket x2 plus x1 upon, like terms will be added. So m plus m, that is 1m plus 1m gives me 2m. Let's reduce. M gets cancelled. So you're left with the value of x2 plus x1 upon 2. Or in other words, x1 plus x2 is equal to 2. That gives you the coordinate of x, provided P is the midpoint of the given side AB. Let's find out how do we calculate the value of y. So let's use the formula to calculate y. So y, by using section formula, is my2 plus ny1 upon m plus n. Again, let's substitute in place of n the value of m, because m and n are equal, as P stands as the midpoint. So y will be equal to my2 plus my1 upon m plus n, because m is equal to n. So m comes out common, into bracket y2 plus y1 upon 1m plus 1m gives me 2m. Again, m and m gets cancelled. So you are left with the answer of y as y2 plus y1 upon 2, or in other words, y1 plus y2 upon 2. So children, when P is the midpoint of AB, we can directly use the midpoint formula to calculate the values of the coordinates of the midpoint as x is equal to x1 plus x2 upon 2 and y is equal to y1 plus y2 upon 2. This is called as section formula, but particular special case that we did was we substituted in terms of n, we put m, so we got only by mathematical calculations the value of x as x1 plus x2 upon 2, y as y1 plus y2 upon 2. But when m is not equal to n, we use the section formula to find out the coordinates of x and y as x is equal to mx2 plus nx1 upon n plus n and y is equal to my2 plus ny1 upon m plus n. To move on with, now let's find out the formula for finding the coordinates of a centroid. For that, let me draw a triangle ABC. First children, before we get the centroid formula, what is a centroid? How do we get a centroid for a triangle? Which point can be called as a centroid? Let's see. For that, first we should know what is a median. So over here children, I have drawn a triangle. Which triangle is it? Let us name it as A, B, C. Let's put the coordinates of A, B, C as x1, y1, x2, y2 and the coordinates of C as x3, y3. To understand and get the centroid formula, first let's understand children, or let's recall what is a median. What is a median? Which segment will be called as a median? We know what is a median. A median is a segment which is drawn from the vertex of a triangle to the midpoint of its opposite side. So if I take point A and join it to the midpoint of the opposite side, that is BC, then AB will be called as the median. How many medians does a triangle have, children? A median, there are 3 medians for a triangle from all the 3 vertices. Which is the second vertex? The second vertex will be B towards the midpoint. Where E is the midpoint, so BE is called as the median of the same triangle ABC. Which vertex is left now? Point C, vertex C. So let's join it to the midpoint. And CF will be called as the median of triangle ABC. So how many medians does a triangle have? A triangle has 3 medians. In this particular case, what are the names of the medians? They are AD. The second one is BE. And the third median of the same triangle is CF. We will just recall the property of a median, children, of a triangle. What happens to all the 3 medians of a triangle? We see that they pass through the same point. And that point of intersection is called as the centroid. Which point is called as a centroid? The point of intersection of all the three medians drawn for a particular triangle is called as a centroid. So let's move on to understand how to get the centroid formula. Now, which is the property of centroid that we have studied earlier? We have studied that the centroid divides the given segment, that is AD, in the ratio of 2:1. Again, BE, the ratio will be 2:1. Then CF, which is the third median, will also be dividing the given median into the ratio 2:1. So we have already learned in the earlier classes that the centroid divides the given median of a triangle in the ratio of 2:1. Let's use this in the section formula to derive the centroid formula. For that, let's particularly only draw one median and move on. So, this is your triangle which I am redrawing again, and let me take only one median so that we do not get confused. Here we are with our triangle A, B, C. Coordinates of A, x1, y1, B, x2, y2, C, x3, y3, and the median was AD. I'll have to mark it with a... Okay. AD is the median, and here you had your point G, which is the centroid point. So this is your centroid. And what does the centroid do? We saw that the centroid divides the given median in the ratio of 2:1. So 2:1 is the ratio. M:(n), that is 2:1. Now children, let's proceed to get the centroid formula. Let us only observe point D with respect to BC. What is point D? It is the midpoint of BC, because AD is the median. And what does a median do? It is a line joining the vertex of a triangle to the midpoint of the base. So what is D ultimately? It is the midpoint of side BC of triangle ABC. So what formula will we use to get the coordinates of point D? It will be only the midpoint formula. So how will we get the coordinates of point D? Here you have the ratio as M:(n), because M and N are equal. So how do we get the ratio as D is the midpoint? It will be x2 plus x3 upon 2, and y will be equal to y2 plus y3 upon 2 are the coordinates of x and y. So now I can substitute and write the coordinates over here. So the coordinate of D are x2 plus x3 upon 2 and y2 plus y3 upon 2. These are the two coordinates of point D. What are we aiming at, children? We are aiming at to get the coordinates of the centroid, that is point G. Let the coordinates be x and y. Now let's concentrate, children. I will just redraw it separately over here. So you have your point A, you have your point D over here, and you have your point G, where the coordinates of point G are xy, the coordinates of point A are x1, y1. What are the coordinates of point D? x2 plus x3 upon 2 and y is y2 plus y3 upon 2. We have to calculate the coordinates of G. So let's begin. What do we do, children? Can we use the midpoint formula over here to get the coordinates of G? Definitely not, because M and N have got different numerical values. So definitely we will use section formula. So here we are going to use section formula to find coordinates of the centroid. So let's begin. X will be equal to, let's recall the formula. X is equal to mx2 plus mx1 upon 2. Now we have to be careful when we are substituting. So m is 2 over here. x2, this you can take as x1, y1. So this will be x2, this will be y2. But what is x2 over here? x2 plus x3 upon 2. x2 plus x3 upon 2 plus, we are just concentrating on the numerator, plus n. What is n? 1. What is x1? It is the same, upon 2. Let's move on logically without making an error. What happens to 2? We are concentrating only on the numerator. 2 gets reduced. So you are just left with x2 plus x3 plus, open the bracket, 1 into x1 is x1 upon 2. We know the addition property, you can rearrange. Therefore, x is equal to x1 plus x2 plus x3 upon 2. So children, what did we get now? We got the x coordinate of the centroid. How do we get the answer? Add up all the x coordinates of the 3 vertices and divide by 2. That will give us the coordinate of the centroid, the x coordinate of the centroid. Same logic will be applied to calculate the y coordinate. So let's begin. The y coordinate, children. Again, the section formula, my2 plus ny1 upon 2. So y is equal to, what is m? M is 2 into y2. Now y2 is y2 plus y3 upon 2 plus, what is n? N is equal to 1. y1 remains as it is. This goes with the numerator divided by 2 in the denominator. Let's proceed. 2 and 2 gets reduced in the numerator. What are you left with? y2 plus y3 plus 1 into y1 gives me y1 upon 2. Let's use the additive property. Let's rearrange y1 plus y2 plus y3. y1 plus y2 plus y3 upon 2. This gives me the y coordinate of the centroid. So how do we calculate the y coordinate? Given the 3 vertices, add up all the 3 coordinates, y coordinates, and divide it by 2 will give me the y coordinate of the centroid. This is called as centroid formula. So children, to sum up with, given to you any triangle, P, Q, R with coordinates x1, y1, x2, y2, x3, y3, and they say that QS is the median which has the point P or which has the point G. You can name it whatever you want, but it is the centroid, and find the coordinates of the centroid, that is find the value of x and y. How do we calculate? So it is simple. X will be equal to x1 plus x2 plus x3 upon 2, which will give me the numerical value of x coordinate of the centroid, and y will be y1 plus y2 plus y3 upon 3, which will give me the numerical value of the y coordinate of the centroid. So this was centroid formula.